So 21 says a quadratic function, so I'm talking about a parent function of x squared, right? And it says a horizontal shift up 2 units, and then, or vertical shift up 2 units, and then a horizontal shift left 3 units. So up 2, left 3. This is not a shrink or a stretch. This is just slides. That's all this is. So my function is going to be, in the parentheses with the x is going to be my horizontal, right? So this is going to be x. If I move left, is it plus or minus? Plus. So x plus 3 squared. And then if I'm up. So up and down is the same. Left and right is opposite. So this is plus 2. That's exactly right. So now if I graph this, right, I've just got that parent function, no shrinks, no stretches. It just takes every point that was originally there. So 0, 0, negative 1, 1. Here's the parent, right? And it takes all of these points and moves them up 2, left 3. So let's do it. Up 1, 2, left 1, 2, 3. There's my new vertex. Up 1, 2, left 1, 2, 3. That's this point. This one would be up 2, left 1, 2, and 3. So there's my graph. What's the domain? Negative infinity to infinity. What's the range? Close. Look at the black parabola. What's the lowest it goes? 2. Somebody said 2. It's 2, right? Because it went up 2. That's why. It went up 2 from where it started. So it goes from 2 to infinity. Yes, no, maybe so? $21. No stretch or shrink here. This is just slides. Just up 2, left 3. That's it. Oh. All right, 22. Somebody said 22 also. Absolute value. So this time, here's my parent, right? And I'm going down 4 and right 5. So my equation in the absolute value signs is going to be my left, right, and my plus or minus 5. I'm moving right, minus 5, and down 4, minus 4. So I take that parent, zero, 0. Here's the parent, right? And each one of these points is going down 4, right 5. 1, 2, 3, 4, and then right 1, 2, 3, 4. There's my vertex. Down 4, right 5. Down 4 and right 5. This one should be a V because it's an absolute value. Come on. What's the domain? Negative to infinity. Left to right. And how about the range? There you go. Negative 4 up to infinity. Yes? Okay. Let's finish stretches and shrinks. I'm not going to lie. I can't remember what we did Friday. What we made it through. Just verticals? Okay. All right, so vertical, just recap. Vertical stretch shrink, it does what it says it's going to do, right? If it's bigger than 1, it's a stretch. If it's smaller than 1, it's a shrink. But it's vertically, so you got to think about like smushing together this way and the graph gets wider, or stretching it out this way and the graph gets skinnier, right? Y'all remember all that? This is just in front of the equation. So if I gave you, let's say I did this. Tell me all the transformations that are happening to this parent. First of all, what is the parent for this one? It's a quadratic, so it's just x squared, right? Tell me the transformations that are happening. What kind of shrink? A vertical shrink of 1/2, that's right. Shrink of, I want to always include that factor there because that tells me a lot of information, right? What else is happening? Reflect over what? Over x. How do you know it's over x and not over y? It's outside. It's in the front. That tells me it's over x. Yeah, this is kind of what we did Friday, and then we'll pull in what else? You don't think we did it? What else? Left how many? How do you feel so far? Tell me if it's a vertical shrink, does that mean I'm getting wider or skinnier? Vertical shrink. Vertical shrink. I'm getting wider, right? Because if you think about, like, remember like that Oreo, you're smushing together and everything comes out the sides of it? All right. Are you looking at the date? This phone? Oh. We used to do that whenever we had to do earthquake. It's a cool little project. I made it myself. Because we learned, because we analyzed remember when all those earthquakes were happening around here? We analyzed the earthquakes that were happening here, and then compared them to all of South Carolina, and then compared them to all the U.S., and then compared them to the world and how they compared. So, no, you can look at it if you want. It's pretty cool, but whenever we get to logs, earthquake, the Richter scale is based on a logarithmic scale. All right. Horizontal, everybody's favorite. It's harder than the vertical.
He literally said it is hard. It's not just harder.
Remember, anything horizontal is opposite of what you think it would be, okay? So this time, and again, utilize your little cheat sheet, okay? Bigger? How much bigger? Is that better? You can't see that? Times. A times X, yeah. Gracie! Did it work? Sorry.
Oh, God.
Take a deep breath and breathe it all the way out as much as you can. And don't hold it until you breathe all the way out, like completely collapse your lungs. Okay, now hold that as long as you can. Don't breathe back in until you can't hold it anymore. This is gonna work. This always works. Everybody thinks you breathe in and you hold it, but if you breathe in really deep and then you breathe everything out and then you hold it. Huh? All right, so this one takes so if I'm looking at an equation, I think it's easier just to show. Did it work? It multiplies just the x in the equation by some value, okay? So maybe if I'm talking about a quadratic, if I had 1/2 x squared, okay? This is no longer, now you're going to see that a vertical shrink is the same thing, and think about it for just a minute. If I squish that Oreo in, right, a vertical shrink could be described the same as a horizontal stretch. Okay? They have different factors to them because I'd have to apply the squared to it, but they are the same thing. So you technically, so some of you will look at this and go, but wait, couldn't I put that on the outside if I wanted to? And the answer is yes. You'd have to do something different. But anyway, just to let you know, so vertical shrink, horizontal stretch are the same thing. And then, but just by different factors. It worked, didn't it? I told you. And yes, and vice versa. So then a vertical stretch would be the same thing as a horizontal stretch. You could, but I'll show you what you have to do. So here, shrink, right. Opposites. Either or, yeah. I'm basically going to tell you about it. All right. Now, I want you to look at this for just a second because this is a horizontal. Now, everything horizontal is opposite. If A is bigger than 1, it's a horizontal shrink of, and I have to flip that A over, okay? And this is on your sheet. This is all on your little, well, yeah, absolutely. Because if it's negative, then it's talking about reflection. And then if it's less than 1, it's a horizontal stretch. Again, I have to flip that A over because it wouldn't make sense if I look at this example and say, oh, that's a horizontal, what is it? Less than 1. It's a horizontal stretch. It wouldn't make sense to say that's a horizontal stretch of 1/2. So we say it's a horizontal stretch of 2. You flip it. Reciprocal, right. Yes. Horizontal. For this example here, it's the flip of it, right. We'll do several examples, I'll show you. So here, A is 1/2, right? So if A is 1/2, then 1 over A would be the flip of A, so it's 2. 1 over 1/2. You never divide by a fraction. Instead, you multiply by the reciprocal, right? So you do top times, flip to the bottom. But RECI?
Yeah, A is the reciprocal, so it's 1 over A. So since half is the original fraction, the reciprocal will be 2 over 1, it's 1 over 2 over 1.
Okay.
Not really, okay.
Just flip it. Flip your A. All right, let me. Not necessarily. Right. Right. Yes. Okay. This would be a horizontal stretch of 2. Look at this one.
Yeah, for real. Y'all think so hard.
What is this one? What's your A here? What's your A?
Yes, 2 over 1.
3 is your A. So this is a horizontal, yes. No, yes, just flip it. Is this a stretch or a shrink? shrink.
I don't know why. Because it is greater.
Further or down? That? Okay. Horizontal shrink of what? Flip it. 1/3.
You
Always flip horizontal. Listen, horizontal's always opposite. Everything horizontal. If you subtract, you're moving right. If you're multiplying, it's the receipt. Everything horizontal is opposite.
No, stretch has to not be a fraction. But it's going to be a fraction because it's opposite. You have to use
Okay. No, just do one. Just do one. Okay. If this, yes, yes.
Okay.
No, but you got to get it right. Understand there's an operation going on here, okay? In other words, here, this is not the same as this. It would have to be 1/4 x squared. So in this case, a horizontal stretch of 2 would be the same thing as a vertical shrink of 1/4 because there's an operation going on there. So that's why I said they're not the same factor every time, but a vertical shrink is always a horizontal stretch and vice versa. But the factors could vary depending on what the function is that you're looking at. So be careful if you want to use them interchangeably. Okay? Yeah. Could you have both in an equation? You absolutely could. And it's easier to take what's given and write it as given, huh? Okay. Let's say, for instance, no? Oh. Tell me what else is happening. Okay, so Madeline says she sees a vertical out front. That tells me there's a vertical. Is it a stretch or a shrink? Vertical. Vertical is what it is. Horizontal's opposite. Stretch of 3.
Right, the fraction. Don't be a stretch. Stretch.
Why? It's opposite, and it's less than 1. Of, flip it. There you go. Yes, yes, yes. On horizontal. Only horizontal. Yes. Somebody said left 1, down 4, and that's absolutely right. Okay, where did I confuse you? Horizontal is always with the X. Yes. Yes. All right, tell me what we got. Vertical shrink of 1/2. There you go. It's a reflect over the y because the negative's inside hook to the x. Uh-oh. Right. Over y. What you got, Cody? Then it's going to be right. It's going to be the same. Right. That's right. But this is going to help us with future functions that you can recognize it. But you're absolutely right. An absolute value reflected over y is just itself. It's a moot point. It stays the same. Gina? Yes. That's correct. That's correct. Kelsey, what you got? Yeah. What you got, Leah? Yes. Yes. On the other one? Oh, yeah. All right. The easy part's identifying it. We got the graph on now. Go back to which one? All right, here's what we're going to do. We're going to stretch shrink first, then reflect, and then we're going to slide. Okay, slide will be the last thing, and it's the easiest. Okay, so once we get them all, and so here's what we're going to do. We're going to take those 3 basic points, 0, 0, 1, 1, negative 1, 1, and those are the 3 points that we're going to stretch and shrink. Okay, and we're going to use the cheat code on your sheet. And I think once you see it in action, you'll see why I'm calling it a cheat code and why I say that. But we had to get our A taken care of. All right. Let's do let's start easy. Yes, yes, yes. So this one, if it's a horizontal stretch, it's going to widen it out, right? I'm going to show you. All right, so here's what we're going to do. If you look at horizontal compressions or stretches, it says take your point, every point that was on your graph, and you're going to divide x by a, and you're going to keep y the same. Now, I will tell you, this is the same thing as, remember where we did the reciprocal of a? This is the same thing as taking that reciprocal of a and multiplying by x, and then keeping y the same. Either way you want to look at it. Or multiply it by 3. Those are doing the same thing. Dividing by 1/3 is the same thing as multiplying by 3. All right, so I'm going to think about that parent graph, right? 0, 0, 1, 1, negative 1, 1, excuse me. A is 1/3, but reciprocal of A is what you multiply x by. That's right, which are the same thing. It's the same thing. All right, so I've got 3 points here. And I always come out to the side when I'm first learning how to do this so that I can, or when I'm first showing you how to do this so you can see how this is going. All right, -1, 1 becomes, I'm going to take the reciprocal of A, which is 3, and I'm going to multiply it by this first one. So that's going to become -3, and y stays the same. For horizontals, y always stays the same. Then I'm going to take the point 0, 0, and that becomes, well, 3 times 0 is 0, and the 0 stays the same. And then that last point is 1, 1. Again, my reciprocal of A is 3, so I do reciprocal of A times x. What do I get? 3, and then y stays the same. So now these are my 3 new points, right? So my new graph looks like -3, 1, 0, 0, and 3. Does that look like a horizontal stretch? If my axes were noodles that I could just stretch out, right, or elastic bands, and I just stretch it out, is that what it would look like? Yes. Yeah. Never divide by a fraction, always multiply by a reciprocal. If I had a whole number there, so like, let's say that was 3. Let's say it was f of x equals multiplied by 1/3. That's right. Or divide by 3, same thing. Whichever way it's set up easier for you to do, it may be easier to divide by the number as it sits, and it may be easier to find the reciprocal and then multiply. If you start out with a fraction, it's probably easier to do the second scenario. If you start out with a whole number, it's probably easier to do that scenario. Whichever. All right, one more example, and then I'm going to let you work on your packet, and this is the part where students always get strung up. It's when we put them all together. Yeah, we're going to finish the packet. And I'm going to give you time to work. I'm actually going to let's look at number 36 together. In fact, it might be easier for me to show you on my camera. What's wrong? All right. Huh? Oh, go to this. All right, so I can look at this one and I can tell a couple of things that have happened, right? I can tell that this graph has moved from the parent. It has definitely moved up 5. Do you agree? What other transformation do you see has happened on this one? A horizontal stretch, or maybe I describe it as a vertical shrink. So here's how I'm going to decide. I'm going to find the first place past this vertex where it looks like it really hits a point exactly. Kind of hard. I'm thinking here. I agree. This looks like the closest one. So I might describe this as both, and I'm gonna tell you why. If I take the point 1, 1, and I make it become 3, 6, okay, because that's the first time it crosses over evenly. Then I've multiplied this by 3, right? So I've done a vertical stretch of 3. And then what about horizontally? I multiplied it by 6. Opposite, shrink, 1, 6. The y did change though. It only changes the y. So if they both change, I can have both of them. Remember that one where it had both? What did I just say? Vertical change. Oh, shame. Sorry. Oh my gosh. Okay, this one's horizontal, right? Plus A. Okay, so horizontal shrink of 1/3. Vertical stretch of 6. The 6 is going to go outside. I got to flip this over, right? That's already been flipped. I need the 3 here, right? Does that now, if I just leave, oh, y'all can't see it. If I just leave it like that, is that a vertical stretch of 6 and a horizontal shrink of 1/3? Yes. And then I need to go up 5. I'm glad you think that's not that bad. This is about as hard as that gets, okay? This was a tough one. All right. Number 2, like this one. X, oh no, not parentheses. It's just x squared. Yeah. Okay. She's like number 2 at the very front. I know I'll have questions on this tomorrow or as you work today, and that's okay because until you work through it. And I think that whenever you get your project today and start looking, it's going to help. All right. Now, project. We're going to talk about the project. This is due Friday. Write that down somewhere, really big, bold, somewhere. When you come in on Friday, this is due. You will have tomorrow and Wednesday, we will do review for your test and project work day. So I'll have all the supplies. So that'll be 2 days worth that you will be working through and doing all that stuff. And I'll have everything set up on this counter over here that you can use. If you need poster paper, I don't have poster paper to give you, but I do have crayons and colored pencils. I have some markers, not many. Some people choose to bring in their own supplies. Some people choose to use whatever they can grab from me. So it's up to you. No, I'm going to tell you about that. Give me just a second. All right, so here's what we're going to do. And let's run through this really quickly. We're going to use, it's kind of like, okay, so the thing that you did whenever I wasn't here that apparently a couple of the equations were wrong, that was using only linear functions to draw a picture. And the domains were restricted there, so they were saying only between these values, and you plug them in. So this time, you're coming up with those equations, and you're coming up with those restrictions so that if you graph it, you get a picture, okay? And we're not using just lines. We're going to use lines, absolute values, and quadratics. Okay, so we're going to shrink, stretch, shift, reflect, all that good stuff, and then cut off right where we need it. So if you look, for example, I've got Desmos pulled up, and I want you to use Desmos to help you because it's going to be an immense time saver, okay? Now, I am well aware that you can Google these type of projects, and you can find them. If you do that, you are going to get a 0, okay?
Can we, like, find a picture online?
You can find a picture and match. So if you look at like the stitch in the back, that's what she did. She found a picture of Stitch that she liked. And what she did, she copied the
And
picture.
put it on a graph?
She actually put it on the Desmos graph and she
Okay,
started,
that's what I
and
was
I watched her, I mean, for days. She sat here and she would start adjusting because what happens is she would start going, okay, I need this to be wider. What's going to make it wider this way? Right? So I could do maybe 1/2 in front and that's going to widen it. But then if I make that number even smaller, maybe 1/5, it's even wider and it's stretching it out, right? Yeah. Well, do you see this in these curly brackets off to the side? I'm restricting it right there. I'm saying keep x between -2 and 2. So maybe I want to see more to the left. Maybe I change this and make it go from -5, and then I want to cut it off right there at 0. And so I could say from -5 to 0.
Can you show us how to put a picture in there?
I don't know how she did that, to be honest. Bella Walker, she moved.
I can text Bella.
That I don't know. I don't know how she did that. Yeah.
I will text Bella.
Now she did that. If you look, that she's the only person I've ever seen do like that. I know the Friends turkey there. So she knew what she wanted it to look like. She printed a picture and put it beside her, and then she kept adjusting until she got it to look close to what she wanted. With what you have to work with, it's harder to get some of the shapes that you need. So she did a really good job with that one. So you have to use all 3 of them, and you have to use at least one of every kind of transformation as you go through. So there's got to be at least one vertical shrink of a parabola. There's got to be at least one vertical stretch of a parabola, at least one, and so on and so forth. So, all right. You must use, and I'm going to just run through these bullets because you're going to have questions about them. Listen up, guys, listen. Okay, so the minimum size, okay, this is for a rough draft if you need it. This is not required. Your picture has to fill up from corner to corner, and that is a minimum. It is going to be harder for you to use a smaller work area, I'm telling you. The bigger your area, the easier it is to graph for sure. Stitch was a lot easier to graph than a really complicated smaller one because there's more, you can make your area a little bigger, your little intervals bigger, okay? I would not advise doing it on a sheet of paper, but if you want and you do a sheet of graph paper, I do have some graph paper. You can see, I think Sullivan she taped like 4 sheets. She did the Angry Birds there that are hanging up. She taped some together. If you want some graph paper to kind of tape together, I do have a big pack of graph paper that I can give you there. Some people want to put rulers and they want to put their coordinate plane on a poster itself, whatever you want to do. A minimum of 20 equations. Most of you are going to find 20 is not going to give you a good picture. Okay, I think those up there, I can't remember. I'd have to pull over and look on the back. There's probably at least 50 for Stitch. There's probably somewhere around 40 for the Friends one. Yeah, so what you'll do, this is the paper that you will give me, okay? So, and if you need more copies of this, I can run them for you. So a minimum of 20, and this is what I'm going through and looking at, and I randomly start plugging into Des. Sometimes I'll graph your whole thing on Desmos and see if it really works, and sometimes I'll just graph some of them. But you'll put your equation, the parent function, so this whole column should either be y equals x squared, or y equals absolute value of x, because those are the 3 you're using. And then the domain you use, but instead of doing it in the curly brackets like this, you're doing it in interval notation. So that interval notation would be parentheses -5, comma 0, close parentheses. Remember how we did that with just like your domain and range is written, okay? So it's going to be the domain essentially of each piece of graph. Does that make sense, everybody? Am I making sense on things I'm saying? No basic functions. Everything's got to have some transformation done to it. You have to have at least one stretch, one shrink, one reflection over x, one reflection over y, one left, one right, one up, one down. That's a minimum, okay? Original, not the same as anyone else, neat and legible. And I can't say that enough, y'all, because there is, for some reason, every year, somebody does this Monsters Inc., the green guy with the one eye. Okay. Everybody always does him because that's whenever you Google Desmos whatever that comes up, and there's always like, please, please, please make sure that it's your own work. This is not a measure of how artistic you are. I am not artistic, but it is fun. Now, some of you will have fun with it because some of you are artsy and you like that more than other people, and you'll do an excellent job with it. And some of us will struggle. I mean, but even like the tulips, like those are super cute and that's good, and that didn't require a lot, you know. So just be thinking.
I don't see the tulips.
See under Mike's foot there up at the top, the 3 tulips that are a bit taller.
So we can do something basic like that.
Absolutely, yeah. As long as you meet the requirements, yeah.
I'm gonna cry even if I do something.
Every, and this is where you'll lose points too. So make sure you pay attention to this. Every equation on your final project has to have a number by it. Okay. And the reason for that is if I look and you say number 5, then I'm going to number 5 on your sheet and I'm saying, is number 5 on their project number 5 that's on your sheet? Does that make sense? So you'll, and if you look at them, you can see all of them. If you look up close, they all have little numbers written by them really small, or they should. Okay. Let's see what else. Bonus points. Everybody always asks about bonus. So this is a project that you don't just get 100 for doing it, right? There's a lot involved with this project. So you'll lose points here and there. It's normal, bless you, to lose points here and there, and that's okay. But there is an opportunity for a bonus points, which is the more complex, the more over the top you take it. You know, you did 50 equations instead of the required 20 or whatever, and it looks really good and it's excellent. I mean, obviously, I keep referencing Stitch. That's probably the best one. The Stitch and then the girl there in watercolors are probably 2 of the best. Bella. Lopez. No. I can see her standing right here and I can't call her first name. Leah. And then Bella's was really good too. Bella Ryder, under the girl with the blue hair. So, just depending on what you do and how well it is, it's just kind of a little bit of opportunity for extra. So, should you get confused, I like to always know what's expected. This is how I'll grade it. There's a rubric on the very last page. And this, I think the rubric only totals up to like 50, so you'll do this and then you'll double it. Okay, whenever you go through and figure out. I don't remember what Noah did. I'm sure they're not all, they used to all be up there and then I ran out of room and I'm not sure what he did. I don't.
I just want mine to make it on the wall.
No, one of them, I think Greer on her unit circle did a turtle and I feel like I had something more. But I don't know. It's hard for me. That was on unit circle, that's for pre-go. Her unit circle, she did the clock. Yes. You can't pull somebody else's like that though. Yeah, a turtle would work. You can stretch out a parabola, but you can't do circles. So his head would look a little lopsided, but make it work. Absolutely.